Well, welcome back to my humble home workshop, and today it is plenty hot, I can tell you. I've kept the fan off so you can hear me. So this is part two of repairing a pulley which was running out of true. And the pulley in question comes from my homemade lathe, and from the very beginning it never ran true, and I decided this is something I need to sort out. So in part one we started to prepare the bush. And in part two we're going to continue to fit the bush and true the pulley and fit it back on the lathe. Okay, we're on 0.763, so we've got 13th hour to go. I'm going to call that to a halt now. For now I'm going to nip upstairs for a cup of tea and take a break, and I'll maybe come back to this tomorrow. In order to finish turn the bush, we need to know the exact diameter of the hole that we've bored in the pulley. So I'm going to determine that with internal calipers. So transfer that to the micrometer. So that's 5/10, so that's 0.7515. Okay. Let's see if we can machine the bush to be an interference fit in that. So we'll just check the current diameter of the sleeve as it is. That's 0.75, 0.762, 0.762. So that means we've got 10 thou to take off the diameter. So we'll touch on that and then remove about 8, and then we'll check again. Okay, after this last cut we've reached 0.7525. Just a touch over 0.752, which is exactly right. That's what we want. So I'm going to put a small lead in on the front there, just to help with fitting it in the bore. Okay, that's our sleeve external diameter turned. I'm not gonna part it. My parting tool is ridiculously wide and over the top for this job, so I'm just going to take it out and use the hacksaw. So there's our sleeve, ready for press fitting in the pulley. Yep, it's wanting to start, so that's a good sign. So what we'll do is we'll clean up the end and then try pressing it in with the vise. So here's the finished sleeve with the other side faced to make sure that when we press it in, we're pressing it in squarely. Because I'm only using my vise here, I'm not using any fancy press. So let's see how it goes. Okay, to start with, I tried to press this in using my vise, but then discovered that the depth of the vise is not sufficient to get the pulley on center line, so that didn't work. So I'm going to use my little anvil and see if we can just tap it in with a hammer and see how that goes. Touch more to go. Perhaps I can try that with a harder piece of wood on top. Let's try this. There we are. Yep, that looks fine. So we've got a nice fit in there. So now we can bore out the sleeve. I've recentered the pulley, doing my best to get the groove true, not worrying too much about the casting or the rim. So it's as good as I can get it. In fact, it's not really round. So what I've decided to do is actually true the groove up. So the next thing to do is set the top slide around. I'm going to cut this outer face first. So we need 36 degrees included angles, so that's 18 degrees off the center line. So I'm just adjusting that, and we can cut one side of the groove. I've already set my tool on center height, and let's just try this in the groove, see how it looks. Okay, I'm just checking for clearance, making sure that we're not going to foul with anything. Yeah, that looks fine. And I've already set the speed to 96 RPM, cast irons, fairly large diameter, so we want to run slowly. And let's have a go at cutting this groove. Okay, that's starting to clean up. The fact that it's touching at 3 points around the circumference at least indicates to me that this pulley is distorted. So it's definitely worth truing up the groove. I'm going to have to relieve the tool slightly because it's just a bit too wide to get to the bottom of the groove. Okay, you should be able to hear now that we've got a continuous cut, so we've screwed up one side by the time I finish this cut. Initially I attempted that with a commercially made high-speed steel tool, and I just wouldn't touch it. It was very, very hard. So I changed to one of my homemade brazed on tungsten carbide tip tools, and even with that it was very hard going, and to get through the skin, eventually I did, but it was certainly tough. Okay, the top side is being rotated around now to 18 degrees off center on the other side to cut the other face of the V groove, and so I've got the left hand turning tool here, which I've just modified slightly by relieving the corner there, so that it can fit into the groove nicely. It's always a good idea to just do a dry run with everything turned off, just to make sure that we've got the clearances we need. And yep, that's fine, so we can start up and face that other side. Okay, that's the groove machined, and the face machined, and the diameter. I couldn't reach the proper dimensions for the depth because I broke out on the inside of the casting here. So there wasn't enough meat left in it to true it up completely. And in fact, if I rotate this, let me just turn the fan off above. And in fact, if I rotate this, you can see where here, just a slight wetness. It didn't quite clean up. I mean, it has mostly, but there's a small wetness left there. And I couldn't do any more about that because there just wasn't enough material left in the pulley. And I think the reason it was out of true is because it was so hard. There were some really hard spots in it, and that's probably why it was out of true in the first place. It was a locally made pulley, very cheaply made, and I adapted it for my use many years ago. I had somebody else bore it out, and when they bored out, they didn't get it true with the rim. Anyway, the rim is now true with the bush, but I need to now machine the bush out to the final dimension and face this. We're just looking for a touch over 5/8, 0.625. So at the moment we are 0.6. Well, I make that 0.624. So we should have about 1.5 thou to go. So I'm going to go very slowly now to get it to size. I'm just going to double check the spindle before I take some final cuts. Well, I'm going to take another cut on the same setting, and we'll see how we get on with that. Well, to me that looks like just 5/10 over 0.625, and the highest point on the shaft is 5/10 over 0.625. So I think I'm going to stop there, and any final fitting that needs to be done I'm going to do to the shaft. I think this bore is fine. If anything out is going to be out, it's going to be the shaft itself. So I'm going to stop there. Just going to chamfer this and then remove it from the chuck. To the reverse side, I'm going to try and face that, but I reckon there are some hard spots here in the casting. So if I can remove the high spots on my grinder, I will. If I can't easily, I might leave this side. At least the outside and the rim are true now with the groove and also with the bore. Now, as I originally had it, when I inherited this pulley from somewhere, there was this 5/16 bolt which I just continued to use. Well, that's not very elegant, so I want to replace it with a proper grub screw. But of course, the problem is that I'm going to have to continue the thread into the sleeve that we've already fitted. So rather than just plunging a drill on the core diameter of the thread and hoping it picks up the center, what I plan to do is to sacrifice the bolt, put that in my lathe, center it, and then drill it with an arbitrary small drill, which I can then touch on the center of the hole at the bottom there on the sleeve, and then use that to transfer my to locate the tapping drill. So that's the plan. We'll see how that goes. So why this setup, you may well ask? Well, I have a 3-jaw chuck which came with the lathe, but the jaws need to be trued, and I haven't got round to that. So the easiest thing was to take the 4-jaw chuck off my other lathe and mount it in here. So that's what I'm going to do. A little bit tricky because the Tommy bar for the 4-jaw chuck doesn't quite clear the larger one. But anyway, I'll manage, and I'll use this to set up the the bolt for drilling on the center. On second thoughts, I decided to cut the head off the bolt. I have no guarantee that the head was concentric with the thread, so I'm just going to face, I've cut the head off, I'm going to face the end of the bolt, and then by eye I'm just going to use the edge of the knife tool to center this. I can't use my clock because it runs in and out of the thread, so that would be near enough. I can probably get it close enough like that. I'm centering the threaded portion of the bolt by placing a piece of white paper underneath with light illuminating the white paper, and then looking down with the knife edge tool just a line parallel with the thread, and just looking at the outside there and checking for run out, and we can get that sufficiently accurate for what we need here. The drilling guide is threaded into the existing hole, and I'm using the same drill to ensure that the pulley is vertical. Now the drill is going to have to be out quite a way in order to prevent the chuck from fouling the top of the pulley. Okay, now we can remove the drilling guide and put through the correct size tapping drill. So for 5/16 Whitworth, that's quite close to a 1/4 inch drill, so I'm going to put that through. The next challenge is to tap the remaining portion of the boss, in other words the bit that's in the sleeve. The problem is that the tap is too short to extend beyond the rim of the pulley, and I can't get anything in there to grip on that, so I'm just going to have to rely on the existing thread in the boss to steady the tap, and I'm going to use a wrench to tap that. I think that's come out okay. Before we take a look at the pulley completed and refitted on the lathe, I just thought I'd show you how it was before. This is a clip from the first video, so you can see just how out of true it was. Okay, the pulley's now fitted, and let's turn on and see how it looks. Okay, possibly the motor needs to be slightly moved to the left to align the central line of the two pulleys, but that's a job for later. So as far as I'm concerned, this job is now finished. Thank you for joining me, and I hope that there's been something of interest here in my humble home workshop.